With question number 20, we are told to graph the linear equation y equals negative 1 over 2x minus 2. Well, again, we were not given a table of values, x comma y's, to fill out, and so this is your clue, your hint, that this question really doesn't require any work in order to graph. Notice our equation, and I'm going to write it again here. So, and how about I use a different color? Y equals negative 1/2 x minus 2. Well, we did a lot of work in class with this type of equation. What form is this equation in? Does this look familiar to you? And hopefully it does. Hopefully you're saying, oh yeah, of course, that is in the slope-intercept form, right? Slope-intercept form. And of course, in this form, y equals mx plus b, there are two key pieces of information that we can quickly identify without any work. We can identify the slope, and we can identify the y-intercept. So the y-intercept, so 0 comma b, whatever the value of b is, and your slope is your rise over your run. So let's ask ourselves, is this given equation in y equals mx plus b? It sure is. So we can identify those two key pieces of information. We can identify the slope. So in this case, the slope is the coefficient of x. In this case, negative 1/2. And we can identify the y-intercept. And remember, the y-intercept is a point. It's an ordered pair. And y-intercepts have 0 for x always. And the y coordinate comes from the equation. So in this case, negative 2. If you have these two pieces of information, you can graph your line without really having to do any work. First things first, you always start by graphing your y-intercept. So let's graph it by hand, and then we'll actually use the software to graph. So let's first plot the y-intercept, 0, negative 2. So we start at 0, 0. And the 0 for the x says don't move left or right any on the x-axis, but you are going to drop down to negative 2. So we drop down to negative 2, and there we have the y-intercept. From your y-intercept, you are then going to use your slope to get to the next point. And in this case, the slope is negative 1/2. So remember, this is the rise part. This is the run part. But because our slope is negative, instead of really rising, we are instead going to fall by how many units? Well, we're going to fall by 1 unit. So if we start at negative 2, we're going to drop down to negative 3, and then we're going to run 2 units. So we're going to, in this case, fall and then run to the right 2 units. So we start at our y-intercept, fall 1 unit, and then run 2 units. So our next point is right there, and then once we've got our 2 points, we know, of course, if we were doing this by hand, would do a much better job than I just did of connecting those 2 points using a straight edge. So that's how we plot and graph a line that's given to us in slope-intercept form. First and foremost, identify your slope and your y-intercept, and once you've got these 2 pieces of information, super easy. First, plot your y-intercept, and from the y-intercept, use your slope, rise over run, to get the next point, and then just connect the 2 ordered pairs that you have on the graph. So let me get rid of everything that's here on the screen so that we can actually get into the graphing screen here. So we know that we want a straight line, so we select the straight line tool here. And again, let's first plot the y-intercept, which we said was negative 2. So we're going to come down to 0, negative 2. And again, make sure that the ordered pair that is in the upper right-hand corner of this yellow box matches what it is that you want to graph. So 0, negative 2, that's what I want as my y-intercept. So I left click once with the mouse, and that locks in that first point. And from there, I want to drop down, based on our slope, 1 unit and run to the right 2 units. So if I start at negative 2, falling by 1 would mean I'm going to go to negative 3, and then I'm going to run to the right 2 units. So I end up at the point 2, negative 3. I'm going to click to lock in that line and save. And once we save, we go back to the test window. You can see that the line we just graphed is now locked in, and we are ready to proceed to question 21.